Hey everyone, Vector Podcast is here, and today we are continuing our quest to study more about vector technologies, embedding technologies, platforms. And today I have a guest from Jina.AI. His name is Joan Fontanals, and he is a principal engineer at Jina.AI. Hey, Joan.
Hello, Dimitri. Nice to meet you.
Yeah, nice to meet you as well. Thanks for joining me today. And I'm really, really excited to talk about what is Jina.AI. I know something. I used to like use some kind of predecessors of Jina.AI in some sense, but not like Jina.AI itself. And but first of all, I would like to you to introduce yourself, your background to our listeners and to me.
So, well, I studied engineering degree in Barcelona, not computer science, some general engineering with thermodynamics, electrical engineering, mechanical engineering. But I got into software engineering because I was related with robotics. And then when I started my professional career, I did software engineering at different companies and industries. And then I got more into data engineering, machine learning, and these kind of fields. And then I also did some work on traditional search, on web search engine, so on. And then just life brought me to China, which was a good step in my career.
Oh yeah, cool. So what caught your eye in Jina.AI as a company and maybe as a technology, as a product, or maybe the team?
So for me, what caught me the eye, it was like the technology and the vision of I see that vector search embedding semantic search in general can revolutionize how we understand search and can bring it to the next level also and adapt to different kind of data or so on and go beyond the typical search bar that we are so much used to.
Yeah, yeah. And I mean, but Gina is like more than just embeddings or kind of, it's more like a ecosystem, right? Like it has like marketplace, it has many different
Yeah,
building blocks and
this is
components.
what I think most of the people that might be hearing us might be wondering much because it's a question that we receive a lot. So we are not another vector database as the ones that have been presented in the podcast. So we are treating the problem of semantic search and we are seeing this as an end-to-end problem. And we are trying to build an ecosystem to help the business and developers to develop their own neural search-based engines. And for that, we are trying to build an ecosystem from the core to our document types. We are also recently launched this Finetuner project to help you with fine tuning your models for your search applications and so on. So we are building a whole family of products and projects
Yeah.
in this around this area of neural search.
Yeah, it sounds quite ambitious, and it sounds like all of these building blocks are really needed for anybody who wants to venture into embedding world of semantic search or, kind of
Yes.
bringing the power of these deep learning models.
So
And
it goes beyond only embedding your data and searching through it. You may want to cut it into different pieces. You may want to re-rank it at the end. You may want to join different modalities together. So we are trying to give and make it easy for the user to develop this application so that they speak the same language, and we hope that they will all speak Jina language, so to
oh
speak.
yeah, oh yeah, for sure. And Jina.AI is open source, right?
Yes.
So can you speak a bit more like towards the business model or kind of how Jina.AI kind of makes money in a way? Like, so basically it's open source, anybody can go and download it and basically leverage in their work, or is there something that like you have some products for which customers can pay and kind of
Right now
combine
we
with
are
open source?
right now we are completely open source. Everything that you can see in our repos and stuff, it's open for everyone right now.
Mhm. Yeah. So okay, and you are like mostly working on backend side of things, so you're not interacting with direct customers, right? Is
No,
that okay? Is
exactly.
that correct?
I'm working mostly on the main products.
And what do you hear about use cases? Like how do they translate to your level of kind of day-to-day job?
So most of our solution engineers, let's say, that are closer to clients and users, they bring us their pain points on how they are trying to solve users' needs,
Hmm.
and some of the main use cases that we're trying to solve come from textual search, image search, multimodal search. That is something that we are trying to excel at. That is going beyond only just using search and text or images to search. Maybe trying to have a combination of both to power search to the next level.
So they might like bring some kind of use case that you need to figure out on tech level, right?
Yes.
Like kind of translates to you. But on the other hand, like you said, it's open source, so it means like there is like a bunch of like GitHub issues coming in, right? And if you have like Slack, or I don't know if you're using Slack, by
Yes,
the way.
we have a Slack.
Yeah, Slack.
So I
So like,
invite everybody to
so
join
like
our
probably,
community.
yeah. So probably every day, like somebody, you wake up and there are like questions there, right? So it's also clients in a way, right?
Yes, for me, the users are our clients, and we have to listen to them. So that's the big point of open source, in my opinion, is this direct feedback from the users. You can correct your direction, and you can measure if your APIs are or your design are too complex for the user to grasp or whatever. So this direct feedback is really useful. But to this point, it's manageable still.
Yeah. But it's also like, I guess I also alluded to this in one of the podcasts. It was with Bob Van Lloyd from Semi. Like, it's also sometimes maybe challenging to keep up with all the questions, right? Like, if you get all these questions, when do you find the answer to kind of really deeply answer? Find time to answer them. Yeah.
So we are trying to grow our team into knowing that the community is something that makes us special, and it's important for us to take care of our community. So we are all trying to keep an eye on the community.
Yeah. I remember like when I was developing like search code, we were using like Apache Solr, and I had to like customize some parts of Solr in Lucene, and I remember like in order for me to kind of get up to speed, I had to go to this mailing list, right? And so there are like thousands and thousands emails. Actually, Apache Solr was super active, like, and still is in many ways. And I was like, how can I keep up with all these questions? But like, I do need to somehow keep up and summarize maybe what is being asked there, in order to understand if it's useful for me or not. Because when you ask a question on the mailing list, or like today on Slack, sometimes you need to be ready to pay back, right? If somebody helped you in the community, like you sometimes need to also pay back. So it's like it's a fair game.
When this is seen in the community, I think it's really pleasant for all the team. When community interacts with each other, and no one in the team has to jump in because they help each other. That's when I think the community really scales and really open source goes to the next level, I would say.
Yeah, it's kind of regenerating itself and kind of the cultural element of it. So,
and the community drives you forward. I mean, it's the driving force of the project from the interaction point and the feature wise as well.
Yeah, sounds good. So John, tell me more about Jina.AI itself, like as a product, let's say, as a technology stack. Like, what can I do as a user, using Jina? And like, is it self-service and so on?
So the main point of Jina is that we want to be with the user from the minute they are experimenting with their search application. So for instance, we are written in Python, and we have really nice APIs in Python to build with your documents that can treat with any type of data, text, images, audio, video. And we are trying to build a really easy to use API for this, for you to run locally your solutions. The first experimental phasing to wrap your code, pre-processing, loading the files, and pre-processing the images or whatever, and embedding them, searching, doing approximate nearest neighbors or exact nearest neighbor search. Then once you have this, we make it easy for you to wrap it in some microservices, what we call executors. So first phase, you deal with these document array types that we have come with. Then you come to the next layer is you have it with executors. So you wrap your logic in different microservices, and then we put it in what we call a flow, that is kind of a pipeline that it's ready to scale locally or remotely or even with Kubernetes, so that you have replication and scalability taken care of. So we are trying to bring you easily from your day zero of development to the production system.
Yeah, yeah, sounds good. Sounds comprehensive. And like, what if I would like to just use like a hosted version? Can I use hosted version from Jina.AI, or do I
At
need
this
to then
moment,
kind of?
we don't offer
There is no
this
hosted
hosted version.
version at this point. Yeah, so it's
No.
basically I need to, it's like a Lego type of thing, right? So I
Yes, exactly.
build my
And we have
solution and deploy.
exactly, and we have even this marketplace, as you said, this with this hub executor, so you can share it publicly or privately with your colleagues or with the community your
Hmm.
building blocks that you may think they are useful for you.
Yeah,
Deep learning models that you have packed,
yeah.
pre-processing options, re-ranking, even vector
Okay.
search solutions.
Yeah. So, and how does it align also for with like companies or hubs like Hugging Face? You know, Hugging Face is also very famous on model side, right? So
Yeah.
like let's say
So
somebody picks a model and wants to bring it to Gina. What's the process there?
it's quite. I would say Hugging Face is quite inspirational for us in this sense, in this marketplace community um, place. It is quite similar, but Gina is this marketplace is related to our executor, so it goes beyond only models. So it's any subsystem, any building block that you can build that is able to be part of this Gina pipeline for
Mhm,
REST. And we are trying to make it userful for you to Dockerize it and use it in any way with a simple API. And
mhm,
we're still
mhm.
working to make it easier every time.
Yeah, of course, because actually, it tends to eat a lot of time, the infrastructure part. Like, how do I bring my model? Let's say I have a custom model and I want to bring it inside Gina, right? So it serves as a embedding layer. So how do I figure out all the scalability or latency parameters and so on? So I think,
So
mhm,
the first thing is to get it working. We are having to we expose these with these executors that have some API and to that read requests with some API inspired with this fast API approach. And then you have with this flow you have the parameters to replicate, to scale, and so on.
mhm,
You may run it in GPU, whatever.
mhm, mhm. Yeah. So like you can choose your cost kind of like factors, right? Or based on your
Yes,
cost factors, you can choose is it CPU or
exactly.
GPU, and then latency impacts. And for some models, actually, CPU is fine. So yeah, I mean, why not?
Yeah, and it depends also on the user needs. So, for instance, we are also seeing that um, neural search may not is not needed to be only for these big giants with this big amount of data and big amount of resources. So any
Yeah.
company, small company, can benefit from the power of deep neural networks to power their search. So they may not need so much resources, or they may not require so much speed. So it's a balance. So we are giving the power more or less to the user.
Yeah, and kind of flexibility of the platform. So, because essentially, if they wanted to do it from scratch, then they would probably need to figure out similar things like component isolation and scaling, and yeah, like an algorithm, like quality checks and so on. And on the algorithm side, you said like you have exact search as well as inexact search. Can you talk a bit more and kind of mention maybe some algorithms that you support? Um,
So
yeah.
So right now, natively, we support as the main native, quite optimized version of the exact nearest neighbor search. But then, for instance, one of these building blocks can be any support wrapping any client for any other vector database. But for instance, we just realized our own approximate nearest neighbor solution. We have two of them, for instance, that we have developed so much. So we have one that is based on HNSW plus a Postgres indexer, plus a Postgres database to record the documents. And then we have built we just released, and in Slack, the community can start enjoying it. We have built what we call Piculite, which works with product quantization, but also has support for HNSW.
You said PQ Lite, or how do you spell that?
Piculite
PQ Lite. Ah,
for
PQ
with
Lite. Is that right?
PQLite
Oh, I see. So
with
it's like product quantization light version.
yes with pre-filtering options as well.
Oh, with preview. And how, in what sense is it light compared to product quantization?
No, I have not been involved so much in this project right now.
Sure.
So it's a new thing, but it is light in terms of that it is quite embedded and it's quite native to work with our document types. So it's not so general as any object, but it is really built to integrate very easily with Jina.
Oh, I see. Like with specific kind of
Yes,
schema or document types,
exactly.
and it's also open source. And do you like, obviously you can provide the link, so we can also link in the show notes. But do you also like have some kind of latency analysis for this algorithm? Like, has it been conducted? Do you know?
Yeah, there is some benchmarks that you can find in the README. I cannot have
Sure.
I don't have the numbers in my head right now.
Yeah, but I think for portion of our audience, it's going to be interesting to check out
Sure.
because, as you know, like actually my team just completed participation in BigANN. I don't know if you heard about this competition. So it's like billion scale approximate nearest neighbor search. So we invented like a new algorithm called BuddyPQ. I will also link in the show notes like the blog post about it. So we increased recall by 12% over FAISS model. So yeah, FAISS algorithm. So yeah, I think it's great that you guys are also inventing
I
algorithm.
don't know if we are testing to this billion scale. I think we are more in the million scale at this
Yeah,
for
actually,
this specific
we also ventured into billion scale, but in the process, we figured out a solution for million scale. So it's not for billion yet. We don't know yet if we can generalize to that level, but I think we can with some additional research. Hmm.
Well, this is the first version, so for sure we will try to improve it.
Yeah, awesome, awesome. This is great. And have you also helped customers to like train models?
No, but we didn't help customers. Well, we did from our solution point of view, but this is an interesting topic because this is something that this is one of the pains that we found quite often with our users. Like it was easy for them to go to that level, 70%, let's say, of accuracy with any deep learning model that all these tech giants have developed, right? But we believe that this last mile, this transfer learning part, is important, and and when we realized, we started this project that is we call no, it's already released, the Finetuner. Maybe we can share the link as well, where
Yep.
we try to make it easy for users to fine tune their models for metric learning search applications, and it is also framework agnostic for we support PyTorch, TensorFlow, and Paddle. So we
Okay.
realized this pain point for the users that once we have everything running and so on, the quality was not as expected, and we are trying to help the user in our ecosystem to get
Yeah.
to this level by using this fine tuner.
So basically, can you explain a bit more about Fontanals? Like basically, what input do I need to provide as a user into this
So
component?
fine tuner, it could feel similar to any PyTorch dataset, for instance, but we are trying to put our documents as the main citizen of our ecosystem. So you have to wrap any of your data into our document types, which is rather easy. So it's something easy to learn and easy to use.
Mm-hmm.
And then you can feed your models, and we have made it easy for you to use the most typical loss functions. We are trying to introduce hard negative mining. We are
Mm-hmm.
trying to make it easy for everyone to solve the common problems having when training for search applications. And we are also trying to make an interactive labeler that helps you interactively through an easy to use UI and tag similar objects so that you can go together with them.
Yeah. So like, um, kind of. I mean, fine tuning can be a pipeline by itself, right? In itself.
Yes.
So like, how do you get these data samples that you want to fine tune on, and you might have them before launch or during test after launch, and it's like a this
Yeah, it's a
cycle
never-ending process.
flywheel of success, so to say,
Yes.
right? So do you cover like the full workflow until
No.
production, including production, or is it like pre-production?
So for now, we are using just the embedding model, and just to get the embeddings that get better semantics out of your data set of your specific use case. But we are in a really, I think it's 0.2 release or something we are in there, so there's a long way to go.
Yeah, for sure. But I mean, the direction is fantastic because that's exactly what addresses the real need, any user, right? Like fine tune, like it's all fancy to take like some Hugging Face model or whatever, but like fine tuning it to the level when your users will love it, that's a different story.
Exactly.
So, yes, that sounds great. But I also wanted to come back to your, like you mentioned that Jina.AI doesn't kind of compare to vector databases, but I do get sometimes questions like, how do these systems compare to each other? And you may or may not know, I've blogged about all vector databases I knew to that point, and turns out there have been 6, and then the 7th one knocked on the door, so it's also now on the blog. But I didn't cover Jina.AI, I didn't cover DeepSet's Haystack, because I thought that Jina and Haystack, they're like layers above a vector database. Is that the right thinking?
Yes, I think it makes sense. We might try to develop our own solutions for the use cases that we may feel more worth. So that is, I mean, the world is out there to do. But yeah, I think it's right. We are trying to. I think vector databases cover one of the parts or one of the challenges, maybe one of the main challenges of vector search or neural search. But we try to see the whole scope and the whole pipeline. So in Jina, we can use, you can wrap some client that will use any of the big vector searches, vector databases that are out there.
Have you done any integration with some vector database before? Or?
Not ourselves right now, but it would be, we might do it in the future.
Okay, yeah, because for now you did mention that you offer KNN and ANN algorithms, which to me sounds like a core building block of a vector database. But then, of course, in vector database you have many more things, right? Like where do you store objects, how you store them, what about filters, and so on.
Yeah, but we are trying to cover from the, for instance, we are not some people for some use cases, just exact nearest neighbor search might work just fine, and they don't need to worry about configuring fancy ANN models for their recall speed requirements. So I think there is room for everyone. So I think it just, you have to offer what is right for the right use case and the right need.
Yeah, of course. And by the way, what's the core programming language used in Jina? Like in different.
So our core programming language is Python, because we are more like since we are this pipeline and we are like a glue ecosystem. Most of our operations are wrapping models that run in optimized languages or something, and that also Python helps us iterate really fast, which other languages might slow us down.
Yeah, that's true. And does it also apply to the ANN algorithms that you mentioned, like PQ Lite? Is it also Python?
I don't know if we are, for instance, I think we are also using some bindings for HNSW.
So it
I
might
was
be.
not so much involved.
So you are using probably C version of HNSW binding to Python, right?
Yes, that is for sure. But I don't know if some of, for the HNSW part, yes. For some other parts, I don't know. We are also maybe Pythonized some of the code. We are trying to optimize wherever we find.
Yeah, but it sounds cool that, you know, if we still continue kind of this comparison a little bit between Jina.AI and vector databases, right? Like vector databases, if you pick them, let's say Viaviate is implemented in Go, Quadrant is implemented in Rust. So these are compiling languages, right? So Vespa is like Java plus some C, I think, C++, and but mostly Java. So like nobody implements a vector search in pure Python because it's gonna be very taxing on the latency, you know.
Sure. No, but the expensive operation we are not running. So for instance, the nearest neighbor search we are based on NumPy operations, which are optimized at NumPy level, and the approximate nearest neighbors, I think most of the code, most of the heavy lifting is done at the C++ level from and just covering our bindings.
Yeah, and I'm still curious about PQ Lite. Like, is it C or is it Python? But I think we need to check the documentation.
Yes,
Yeah,
exactly.
I'm curious because like I've actually invented a new algorithm in ANN search, but I haven't published it widely. It's open source, but I haven't like done the thorough benchmarking. And what I faced is that like in Python, even though I optimized all parts of the algorithm, I'm using pre-allocation and NumPy, it still runs out of memory, runs out of memory as in it leaks memory, and it doesn't explain, like Python virtual machine doesn't tell you where, like you don't have tools. Okay, there are some tools, but they're not useful. Like
No,
not
you
the
should
same
assume
level as
that it
Java.
never happens. No,
So yeah, and I've been like a little bit like desperate, and I've been thinking, okay, should I now move into Rust Go territory, which might be a little bit more dangerous, like even though I do have some experience in C++, but like, do I want to go there now? Like Python is much more comfortable.
I think depends on the layer you are working with, and it's so. I think that by offering Python APIs in the field of machine learning will attract and will make everybody much easier to use.
Hmm.
Then, if you get the API right, the API is right, you might then bind to whatever of your favorite languages. But I think getting the comfortable API for the developer to use and to love using is one of the key first steps.
So do you invest a lot into building these APIs? Can you give an example of like some API within Gina that kind of makes the workflow easier for?
So, for instance, we are trying to improve a lot in this document. So, document is our central object, and document array is these are the two core members of our family in the ecosystem. So, we are spending a lot of time on making them easy to use. For instance, with this fluent pattern, we are trying to invest a lot of time on finding the best way, the more Pythonic way to work on it.
Yeah.
And yeah, so it's a constant evolution, try and error. Yeah.
Yeah, of course, but it's like APIs is like exactly that layer which is essentially like facing the customer, right? And
Yeah.
you
For
don't
us,
know the scenarios they will use it in, and sometimes they might kind of surprise you, or they might say, okay, I found some workaround for your like missing parts, but then you think, okay, I didn't think about it, right? So that
exactly.
the API layer is a fantastic way of talking to your client through like API contract in a way, right?
Yeah. And it's a quite a big challenge, I would say, to have the right balance between ease of use and flexibility. So what belongs there and what doesn't belong there, because there's always a risk that to put too much functionality in one same thing and make it very powerful, but make it a nightmare to use.
Yeah.
So this in this balance, I think there is the key to
So
success in
what is
this.
your choice when you have to choose? Let's say, is it balance of flexibility, or like flexibility, or what did you say? The ease of use, right? So
Ease
how?
of use. I think we are now. I'm now tending to go for the ease of use because, for instance, with this open source, I repeat that open source teaches you well. I think at some point we didn't nail it down so well, the APIs, and it was a little bit complex to use. You could do a lot of things, but at the end, maybe not everybody was doing. So I think ease of use for the first entry barrier is the most important.
Yeah, and I mean, also like it's interesting, like if you have a real API, let's say deployed somewhere, and it's a published contract, and people are sending queries there, then actually which endpoints, which features are being used, which are not, which options are completely ignored, even though you put them in the docs, right? But how do you go about this in the open source code? Like somebody downloads your code, they use it somewhere, you don't know how. So how do you collect this analytics from them? Do you just send like call out messages, hey guys, what do you use, what you don't?
Right now, we are trying to keep attention on who is using us, what, and when people ask us, we try to get the most information out of them, not
Mhm.
information of the business of how they use it, how they feel. So right now, the community is the only source of information we have. That's the open source world.
But how do you talk to them? Like, do you like send Slack messages saying, hey guys, can you vote about keeping this feature and removing that one? Or
not exactly like this, but you see people that are more engaged or more or less engaged, people that are more finding it more easier or less or having more difficulties with your solution. So it's, and sometimes we have a developer relations teams that try to get also feedback from the community in any terms.
Mm-hmm.
So this is a global effort from
but
the
but
company.
but in the end, you have a say, right? Like no matter what they
Yes.
ask, you have a say. Is that right?
Well, I mean, sometimes you cannot um, please the community to all the extent. I don't know. We have to keep a roadmap. For instance, people may want you to build something that is ML related, but maybe not so significant for search solutions. This is quite a confusion, I think, also there.
So beyond search, like where can I use Jina.AI? What kind of other use cases have you seen beyond like kind of similarity search, let's say?
So since we are building these abstractions, it is quite easy for you to use these abstractions for building any classification model or anything machine learning related. You could even deploy something and use Gina to easily deploy and scale and use your segmenter object segmenter model. But this is something that you could do, but Gina is born and will be working to implement neural search solutions. So you could still use this, but might not be the best tool for it. So we are
Mm-hmm.
not born for that, but you could do it. But we can see that we are done. You can do this because, for instance, classification or segmenting an object can be part of your pipeline. But in theory, we are born to support search applications.
Yeah. So like
Or
it
for
would be
instance,
interesting.
something that is or search applications or something that you can frame as a search application right now. For instance, a question answering system that you can frame as a part where you will do some similarity search or sparse search, and then you have some reader model that extracts more information from something. So
Yeah.
anything that falls into this domain, you can do it.
Yeah, I guess you can also like based on the research and some practice happening in data augmentation based on retrieving, you can also formulate data augmentation as a process of search in principle,
Yes.
right? So the output will be your augmented data, but you use search in in the middle.
Yes, actually, that might be, but search can be, so many problems can be framed into search. I don't know. At the end, is like vectors are somehow like the truth, no, like the semantic information. Somehow we don't understand exactly why what is encoded there, right? So just by clustering them together, somehow we have some understanding.
Mm-hmm.
So many things you can frame with like
Yeah.
this.
I also wanted to ask you a little bit like closer to the similarity search itself. You know, let's say I build a traditional kind of text search engine, okay? And I'm
Yeah.
moving away from BM25, which is like probably majority of this market today.
Yes.
So I'm thinking, okay, what are these cool kids doing? Maybe I should try it out, plug in some BERT model. And But then in my UI, I'm also showing snippets, and it's very easy to show snippets when it's a keyword search, right?
Yeah.
So what should I do, or what can I do with model like BERT and Jina.AI to show snippets or something that will resemble snippets to the users?
Maybe you can also chunk your information so that you check where the attention is put in your model or somehow. But yeah, I think also there is a thing that we are framed and we have been grown into this keyword search that it's so interpretable and so easy to use and even so easy to hack somehow. No, you as a user know how to drive your next search if you didn't find it right. Okay, this word might fine tune here, and I think since these models are kind of black box for many of us, I think in this kind of sense, this interpretability is one of the main challenges, and I think one of the main focus that research should go.
Yeah, but I mean, you call it out as a interpretability, but like for the users and for me, let's say I'm a product manager, I don't care about is it BERT model or is it BM25. I used to see snippets. I want to see them now. So like, what should I
Yeah, but
do?
the point is
Yeah.
in VM25, I can give you a snippet because I know why I have this solution. Here is, well, it correlates, but where the information that I want is there. Maybe, for instance, in Jina, one of the main building blocks that we have is our document is a recursive structure, because most of the things, for instance, if you if you search a document, a textual document, you might need to break into paragraphs, into text, and so on. So maybe what you can do is you do the vector search at the granularity level is at sentence level, but then the results might be shown at paragraph or at sentence level. So you can highlight very easily the sentence that really drove this search to this page. That could be a use case.
Yeah. I remember actually, I don't know if you know the blog, was it Salmon Run, like Sujit Pal? It's he's doing a lot of blogging in the area of like here is the problem, how do I solve it, and then he quite usually he goes into deep learning or like trying out some vector search maybe or not. And I remember like he was saying that to solve this snippeting problem, how he would do it, because he comes from traditional searches, I do in a way. And like he said, okay, you can kind of build like, if I remember correctly, if you can build like almost like a dictionary, right? So let's say you take a word, you can embed it. Take a word, you can embed it. Like you can embed a dictionary, right? Now, when you found that document, you can kind of, from embeddings, you can map back to the words. If they happen to be close enough, like geometrically, you can find close enough words. So you can kind of try to say, okay, maybe these keywords are representative of this text, but I'm not 100% sure, but at least you try. So you go backwards, like reverse engineering from the embeddings.
It's an interesting thought, though you may need to go through all the pain of lemmatizing and all this kind of stuff that you may have saved by going through semantic search, and now you are back to it. So, like, it's trade-offs. But yeah, it might be a good.
Yeah, lemmatization is another thing, but like I think there was this paper from, I believe, Google about byte level kind of training, right? So they don't care if it's like lemma or if it's like suffix or prefix. They just go byte level. They don't go sub word level. They go byte level. And then with byte level, you can essentially kind of like, okay, now I can compute the distance again, right? Okay, how close is this to this dictionary word or not? But then again, from there, in order to produce a snippet that will look like natural language, you will have to use some kind of model like GPT or like, to generate the sentence. And at that point, it might actually go completely different direction from your text, right? Start like hallucinating or write a news item that doesn't exist. So, yeah.
Yeah. Well, maybe you can use these extractive models where from a sentence, given a context, but not sure. All these top-notch research is crazy.
Yeah. But I mean, like attention, what you mentioned, attention probably can be used here, right? So like you can ask the model, okay, what did you pay attention to when you did the matching? But still, it's not. Some people, as you say, like you can say it interpretability, but on that hand, it's kind of like when you go specifically to that product case, you need that snippet or you need that kind of context of the match. Or like if you said mathematics and it picked algebra, like why did it pick algebra? At least can you explain? Because here it's more or less obvious, but in a specific domain it might not be, right?
Yeah.
So like what do we
It
do?
is hard. And maybe you are not using the right tool. I don't know. Maybe we are obsessed on using the deep learning for everything. But I think these two walls of keyword, what we call traditional search and this neural search, I think they can be combined to power things to the next level. I think they don't need to be enemies, and there is good and bad in both sides.
Do you have any thoughts how you would combine?
For instance, in any solution, you can have solution. I don't know. Maybe you can get results based on both sides, and then at a ranking step, consider what is best. I don't know. Is this a complex? Is this a complex query? Maybe I'm looking more for some semantically rich solution. did this guy just, is this user just send a couple of keywords? Is it semantically rich enough? No, this user might be expecting keyword based feedback.
Yeah.
I don't know.
Yeah, that's true. Or like you could even like go as simple as kind of giving that control to users, right? So like
Yeah,
if
for
they
instance.
know that it's keyword, they first want to go with what they know what works or may not
Yes.
work, and then only if they are not satisfied enough, then they optimize for recall. They might go into explorative mode and then put on the similarity search. Yeah, I mean that might be quite viable. Sounds interesting.
The problem is that keyword search, well, sparse search, it might have not a good future for image-based search or any other modality-related search.
Yeah,
Here,
exactly. Like the moment you go beyond text, right?
yeah,
What do you do?
that's the big power I think, and the big future that neural search has ahead.
Yeah.
There is where not any traditional search solution I think will keep up.
So if I want to build like a multimodal search, can I pick some executor from the marketplace and plug it into Jina today and do it?
Yeah, I don't know in the, yeah, I think we have some, for instance, but you can use clip.
Yeah.
That clip, you can use clip to encode. I think there is audio and text, or there is image and text, and it performs very well. We have wrapped it in one of these executors and hub modules, and you can use these clip models to do your cross model search, for instance.
Mm-hmm.
You can, it's quite efficient without much fine tuning
Mm-hmm.
to search for images given text and the other way around. It's quite impressive.
Yeah, that sounds cool. And I was thinking like if I want to combine like speech, text, and image, then I need to probably come up with some meta model of that, right?
There is some research in this area where it is not that like modalities are treated differently and encoded separately, but where they are considered together. Even there is some research where there is multimodality and some context switch, so they move the vector. So that's also possible to get the latest research, wrap it into one of these models, and deploy it in production. But this is not so easy for us. We didn't focus on building this from scratch, but it, we also look into having these top-notch researchers into building these modules in Jina.
So like in that case, would you prefer like community to help out to bring in the model, or are you helping to do that as
Right
well?
now, we are driving this direction to offer this to the community. But I think that our dream as an open source software is to have the community flourish and be alive on itself. So the future should be community driven.
Yeah, yeah. Because in the end, community might also know kind of well when this grows big, community will be kind of helping each other.
Yes.
Like some of these things will become what you may call commodity to some extent, right? Or at least the way you integrate might become commodity, and the use cases might become commodity, and there will be new use cases which are untapped. But I think community can definitely help out each other
What we
in
might
terms of.
need to focus on to make these models easier to use or easier to find. If we have a marketplace where everything, maybe we need to help the community on finding what they need in at every time.
Yeah, yeah.
But content wise, hopefully there is a time where community is the main contributor there.
Was there something else in Gina that we should know about as users? Some cool feature or some system that you think doesn't exist in competitors? Something at all useful?
I don't know right now about competitors. So I think that what I like the most is the ease of use and the time saving um, method. If you go out to our README and you try to build from zero to deploy in Kubernetes a neural search solution, an image search solution, I think you will all enjoy the easiness.
Yeah, yeah. So it's like kind of well-oiled machine. But like, can I also bring it up on my laptop?
Yes,
Like,
you can try on your laptop
so,
everything. So the
um,
point is, just you may not be able to index so many images, but you can you can get the first feeling in your laptop.
Yeah, I mean, I'm if I want to build like a demo to impress my manager, so I usually use my laptop, right? Like
Exactly.
that's maybe one way.
Jina is
And
ready for that.
yeah, that's pretty cool. And I think also like it's nice that you said it's Python friendly, so it opens doors to so many things like especially like on Hugging Face, it's pretty much all Python, right? So I need to pick some model, plug it in, and don't need to containerize it maybe or figure out isolation and so on. Like just plug it in and start using it. I think that's also a great boost to productivity and actually kind of implementing the use case rather than focusing on some mundane components and parts and processes, right?
Yeah, and even these modules that we have, they are already containerized for you. So we have on our end, we build a container for you so that you can build it in an isolated way with your all your dependencies and stuff.
Yeah, yeah. Sounds great. I mean, I think we now have pretty good understanding of Gina. Of course, we didn't read the docs yet, but at least it sounds promising. So I hope some of our listeners and audience will check it out. I wanted to go more into this kind of philosophical level. Like, what drives you in this space? Like you said that you've been working in web scale search as well before, right? And like some other search and
I
engineering
was
in general. So
I
like
was working.
what drives you here now in this area when you joined Gina, and why you joined Gina?
So I joined Gina, especially yes, I was in this traditional search space. I was working on training ranking models. So, but what drove me more is to enable this search system, these search experiences beyond text. I was super curious about how we can. It's impressive to me how the same framework of getting something that extracts meaningful vectors with semantic information can be used for images, for video, for audio, for anything. These frameworks, I think it has a lot of future because it's quite, and also how the different research areas from different modalities interact with each other. I don't know. The convolutional neural network appeared, even some text classification used to do this. Then appeared the transformer. Right now, the computer vision community is getting in love with transformers. This back and forth, I think that it's impressive. But also, if you think of the magic of getting this vector and having so much meaning there, it's quite amazing.
Yeah, it's true. I mean, it feels very powerful. Like that the sheer fact that you don't need to build a synonym like dictionary if you go full text, right? Like it just tells you that yeah, mathematics is close to algebra, or like you throw data at it and it's unsupervised, right? It just tells you, hey, I've trained it up, like now okay, I can tell you what's close to each other geometrically. It also has the mathematical beauty there, right? Like geometric closeness rather than kind of some obscure, strange, abstract, sparse closeness.
It's quite elegant, I would
Yeah,
say.
yeah,
No,
yeah,
you abstract all this knowledge, all this, and you have this simple thing that you can imagine in your head as a 3D space, and that is simple as algebra from I don't know which grade, but quite simple. Yeah, I think in simplicity there is a lot of beauty.
yeah. It's very easy to explain to your granny. Like I'm doing this, like it's a
Yeah,
3D space kind of. There are points, and I'm just looking the closest one.
I
That
expect
yeah,
to have something that puts things close to each other that makes sense together. That is
yeah,
what we expect from this black box.
exactly. And then the question of scale, like if you go to 10 million, 100 million, billion, then okay, can you trade some of that closeness, precision, and kind of get faster speed? So yeah, it's very interesting. I mean, it's does it does it interest you more like on deep learning side or on mathematics side or engineering side, like or maybe some other side?
In every side, from mathematics, I enjoy a lot the beauty of it. Sometimes it's too obscure for me, but I really like and understand. Deep learning, I like it, although I feel that some of some of the research. doesn't seem to be so innovative, and maybe we should spend more time checking other paths. And
Okay.
deep learning sometimes
Which other
is,
paths like
I don't know.
you suggest?
That's, to be honest, I don't know. I just feel that there's so much literature that I cannot keep up with. And then from an engineering side, I think it's cool because it's a space I think I also can provide more value. Deep learning, sometimes concepts are too abstract for me.
Yeah, like for me, like I want to call out your like point on is deep learning the only way? You know, like for example, one scary thing is that these models are becoming more and more kind of parameterized. So you have like hundreds of millions parameters, maybe billion, trillion. Like how many more can you have? Zillion parameters in there. But first of all, it's impractical. So if you take that model, you try to plug it in, it doesn't plug in because it's too expensive. And also, you might not have that much data in the first place, right? So why should you care? Like web scale search engines probably will, but like you as a researcher in, let's say, a startup, you don't know if you need that much. You need to solve that specific thing, right? So it will look really strange to bring this huge microscope like GPT model in and say this is what we need to use, and then like the whole budget goes into paying that model or whatever, you know, like it's impractical. So that direction by itself, like I think it's a little bit like doomed, or like I don't know, like how you feel about it.
Yeah, it's a race where I add another layer and get more parameters and I win. And I think I'm not, but it feels that the first step to move away from this is to really understand how things are learned and why are learned the way they are. I don't know. In image, you have these models to bring back to the image where the filters are learned more or less. You have some idea or where the model is looking, but maybe to put more research on slow down. Let's slow down this race and let's understand, and maybe we find a way to make it more sustainable for
Yeah.
everyone.
Yeah, because I remember like when I was doing my PhD in machine translation, it was using like statistical models like Moses and, you know, statistical machine translation. And so it would suffer from things like out of vocabulary and, you know, how do I bring syntax in and whatnot. But then, like when deep learning came, like all of a sudden you see that it translates much, much better. And you think, wow, probably they solved it now, right? The claim from 50s that we will solve machine translation probably now is delivered, that the promise. But then you notice it's fluent, but it's kind of like I don't want to use the word stupid, but it just doesn't get it, right? Like it may swap subject and object easily. It may go and hallucinate about something that doesn't exist there, or it actually goes and translates into like single letters all of a sudden, you know, or repeating n-grams, or like you see that it didn't exactly solve it, right?
You wouldn't trust your life to such systems yet. No.
Yeah, and then you kind of come back and like, okay, and I used to do it like in a rule-based approach, so I could understand the syntax of the sentence and then semantics of each like node in the tree. And then when I translate, I use some semantic like function, and it's all well defined in the taxonomy of semantic functions and so on. Like, okay, now I go back to deep learning. Do you have anything like that? No, it's like just space.
Maybe there should be a way to combine. I don't know. We have built, I think, as humans, we have built this complex way of talking to each other, no, with semantics. I mean, multiple languages and stuff, and there is no way that all these language can go back to this deep learning ruled world. It seems counterintuitive, at least.
Yeah, yeah. So you are certain that like maybe the voice of those who build alternative models to deep learning or alternative approach should be maybe louder.
Yeah, I think that we may suffer from the bias of the winner. No, I mean, maybe the first one who opens a door might not win the race because, but even if they show another way that the race might go, I think they might deserve more attention.
Yeah, yeah. Yeah, this is quite deep. Thanks for this why section. Like you think about it a lot. Like kind of okay, not to be biased. Okay, yes, there are challenges, but it might not be the only right approach. And giving your experience as well. Like you can judge a little bit, like with your open eyes. Yeah, this is
I
really
think
good.
we should explore more, and maybe not all focus on that.
Yeah, and probably explore with Gina, right? That's the
That
goal.
for sure.
Yeah. So this is super great. Is there something you want to share? You already shared that the Finetuner is available, so our listeners can go and check it out, right? Is there something else that like we need to be
So
expecting?
soon, and early next year, we should be releasing our 3.0 version. So stay tuned for that. There are
Yeah,
a lot of news
absolutely.
to come, and we will be moving fast in the next times.
Yeah, this is fantastic. I mean, thanks so much for all this information and detail on Gina, and also like your ambition and kind of like your thinking here. I mean, it's really nice that you keep your open mind um, available to all of our listeners. Yeah, thanks so much. It was a pleasure to talk to you, John, today.
Thank you. I enjoyed too much.
Yeah, thank you very much. Looking forward for 3.0.
Yeah.
All right,
Thank you.
cheers. Bye bye.
Bye.